Yo, what's up, people? This is Robert Bassano, Planete Veritas. It's not what you know, it's what you can prove. Setting the truth free from a lifetime of bondage. We're going to be talking about flat earth math response. My boy John, my partner in crime, is going to be answering a few questions and issuing a few rebuttals to what flat earth math said in the first hour or so of the hangout we did yesterday with regard to the invite we gave to Flat Earth Math to talk about, a wide variety of things. So John wasn't there for the first, I think, hour and 50 minutes, maybe 2 hours, first part of the video, and he had a chance to look at it and listen to what Flat Earth Math had to say, which I didn't challenge it. I let him say what he wanted to say. I told him that I would just let him do his thing, and then we would go through a Q&A session to decipher, not what's fact and what's fiction, but what's reality and what's convoluted and what's delusional. So apparently John has found a few things that just were not referenced correctly, cited properly, and described in a manner consistent with what we all believe. Okay? And for the record, again, I keep having to say this shit. I do not believe the entire earth is flat. The ground we walk on, drive on, and live on is relatively flat and undergoing continual flattening. All right? We're starting to see a lot more puddles of water accumulate in other places that they didn't accumulate, which means that the earth is continuing to undergo flattening, and you're getting some sort of concave type of surface where water can collect to, not running back down to the oceans like it used to. It just gets absorbed in the earth. But the rest of the system is a multi-layered pressurized gaseous environment creating some sort of atmospheric scattering that allows that for you, when you go up at high altitude, you see anything from high altitude, you're witnessing what you believe to be curvature of the earth. Therefore, you are assuming that the entire earth has got to be some sort of egg or ball or just warped ass balloon. Okay? So I want to make that straight right here and now. All right. So, to no further ado, I got Robert Shortman here. He's going to be talking back and forth with John. John's going to do his presentation to address the things that Flat Earth Math said. Flat Earth Math, you're going to listen to this. It's up to you if you want to put out a video to respond to John, or you can accept another invitation to do another live discussion with him, not debate, but discussion to show what you know. You're a math teacher. We want to see the math, okay? The math. John may not believe in the math, but I do. And things can be explained mathematically. That's your wheelhouse. Don't go off of what, we're not going to listen to what you have to say. We want to see it, okay? So, Johnny, you got the floor. Robert Shortman, go for it. Q&A. I am muting the mic.
Yes, sir. Thanks.
Thank you.
Can you pull my screen up?
Dude, your screen is up. You are sharing your screen.
Yep.
There you go.
Now I am.
Yep.
Okay, Robert, it's not that I don't believe in math. You said I don't believe in math explains. Well, that's correct, because math doesn't explain. Math only describes. There's a big difference between explanations and descriptions. However, like you said, the first hour and a half, I had an event come up. I couldn't get in, but I listened to the video later that night, and I found some issues with it. We'll get to those. There was a lot of them. A lot I didn't cover because it would take too long. I just pulled out some things real quick. But before we get to that, I'd like to go over the entropy questions. Again, I've been getting a lot of emails stating some misunderstandings with this concept. So I figured I'd go back over this one more time. So we got the big thing was the sea level right up here, the 760 tour, and in comparison to the interstellar deep space tours. Now, I said that these were exponential magnitudes, which they are, as anyone can clearly see. These are exponential moves right here. So, the problem might be, too, that people are getting confused with torrs and pounds per square inch. Don't let that be a stumbling block. All you have to do is do a little dimensional analysis, and you can convert between torrs and pounds per square inch. It's not a big deal. In fact, it's moot. We can just eliminate the units of measure here. We could just go with concentration gradients, because concentration gradients, that is the density, and is directly proportional to pressures with gases. So we can just get rid of the units. It really doesn't matter. So he said that these weren't exponential magnitudes, and I beg to differ. As we can all see and as we all learn, each of these places here are decimal places, correct? So each move is an exponential move or an order of magnitude. 0, tens, hundreds, thousands, hundred thousands, millions. We learned this in primary school. I'm sure everyone did. And like I said, each move to the left or the right is an exponential move. What we're doing here is we're comparing sea level with interstellar deep space. We're trying to look at the gradient, and everyone can see the gradient right here. But I'm going to break it down even further. I mean, we can see these numbers right here. I put 760 here to denote all the decimal places. But really, this is a fraction. It should be represented technically 760 over 1, correct?
Yep.
Now we look at the interstellar deep space at 10 to the negative 17th. It's right here, right? More precisely, this is a fraction right here. And the fraction is 1 over 100 quadrillion.
That's incredible.
As we've all learned, right down here, the part, 760, and the whole, 1. And the part, 1 over the whole. The denominator is the whole. Just for general purpose, that this is in the 100 trillionths place, the 0. And this is the 100 quadrillionths. These numbers are absolutely massive. So, at 760 at sea level is basically, like we said, 760 over 1. That's 760 parts in 1. For our discussion, compared to the 10 to the negative 17th interstellar space, which is 1 part in 100 quadrillion. This is massive. This is a massive concentration gradient. I'm going to show you. Therefore, if I had 2 boxes, a sea level box and a vacuum of space box, each having 100 quadrillion cubic centimeters of volume, the sea level box would contain 7.6 sextillion particles, compared to the vacuum of space box, which has 1 particle in the whole box. This is a massive concentration gradient. It's almost incomprehensible. So let's do another one.
That's why they
Go ahead, Robert. Do you have a question?
Yeah, I think that's why they don't put the astronauts in those deep, industrial vacuums, because of that. Because that's just a mild gradient.
Oh, yeah. If any small mistake, look out.
But yeah, sorry, carry on.
So we'll do another one. We'll come back here. I'm sorry. We'll come back up here to, I think I did the 50 miles and the 160, and you could, or 186 miles, or 180 miles. You could see the difference, the magnitude here, right? Yeah, you subtract these. We're going to do it right now. But it's a comparison. So we'll do another one. It's at 50 miles high. It's 10 to the negative 3. Like I said, we can disregard the units of measure here. They make no difference. While at 180 miles, it's 10 to the negative 9. So the difference between that is the concentration gradient. It's 10 to the negative 6. So at 50 miles, there's 1 part in 1,000. But at 130 miles away, There's 1 part in a million. That's orders of magnitude or exponential magnitudes. It's as simple as that. So, again, can you or anyone else please answer the question coherently? How can you have a vacuum space attached to a non-vacuum Earth and still retain the properties of a vacuum and a non-vacuum in the same system simultaneously? If there's a non-perfect vacuum surrounding the Earth's atmospheric layers, as we're told, then there should be a colossal cascading chain of envelopment from the exosphere to the thermosphere to the mesosphere down to your feet like dominoes faster than you could say entropy until equilibrium is reached. This is a hard stop. Just so there's no misunderstanding. If your theory is found to be against the second law of thermodynamics, I can give you no hope. There is nothing for your theory but to collapse in the deepest humiliation. And this was done by Arthur Eddington in The Nature of the Physical World, and there's a page number for it. Okay, there was another piece of confusion about the column of water, and me and Flat Earth Math had some back and forth this morning on the comments page, and he went ahead and solidified his position right here, and I'll tell you what he said. I meant that you will fill the entire thing with water, not just 5 feet of it. We all know that liquids and gases move from high pressure to low pressure unless otherwise encumbered. But in that tube, the pressure at the bottom will be 1,220 milligrams mercury, while 1/16 of an inch deep at the top, it will be 760 milligrams mercury. Yet the water doesn't move. Why? Gravity yet again. And that was his comment. So here's my rebuttal. And I told this to him basically on the comment section. Number one, it's factually incorrect. This is factually incorrect. It's a false analogy, comparison fallacy, and a straw man fallacy. Before we get to those, let's get to gravity, his last statement. Gravity, it's a fairy tale. Please validate via the scientific method that it's the cause. Period. So back to the blue point up here. Water, liquids, and gases are two different animals. Even more so with entropy considerations. Why? Well, water is a liquid for one, and it has intermolecular bonds hindering at play. Gases don't. As you can see here, in solids and liquids, you got hydrogen bonds interacting. What's the difference between these and gases? Well, you have no bonds or intermolecular bonds at all. Big difference here, and especially it's a massive difference in the subject we're discussing. More importantly, as we decrease the pressure on a gas, the volume increases immediately, which in turn increases entropy. Pressure effects on liquids or solids with respect to volume, hence entropy, are minuscule as compared to gases. And I said see intermolecular bond forces and others. And water does move. It's one of the main reasons for currents. See the ocean. But as mentioned previously, the pressure effects on liquids and solids is minuscule as opposed to gases. We all know this. That's what a gas is. There's no bonds in gases. That means they're freely allowed to move, and they fill their container. My argument is gases, not liquids or solids, with vacuums and non-vacuums, not liquids or solids in a column. So, ergo, it's a straw man fallacy. Now, here's a direct comparison, and I brought this up during our discussion. Take an empty liter bottle of soda, suck the air out, and replace the cap quickly. Ensure the sides of the container are somewhat collapsed, denoting a very minor vacuum. We've all done this before. Pound a 3-inch nail through a small sheet of 1/4-inch plywood and lay the board flat on the ground, butt it up against strong gravity because you're against the ground, and with the business end of the nail in the vertical position, Go ahead and puncture the bottom of the bottle with the nail and tell us what happens. We all know what happens, correct? Air's going to rush into the bottle from high pressure to lower pressure. But my claim is I'm flipping the script. I'm making it even more problematic, where you have exponentially stronger vacuum with an exponentially weaker gravity. So what do you suppose will happen then? The exact opposite? No. No, it won't. We all know what's going to happen. So, at 1318, in the video, you said there's no proof of anything. And my rebuttal is, have you heard of science before? Or the scientific method by chance? Let's take a look. Unless it is hindered, and we already did this one, in nature, heat flows from hot to cold always. Energy concentrated to dispersed always. High pressure to low pressure always. Nature, natural law, cannot create or destroy matter or energy. Are we knowing stuff? Could we prove these things? I think so. Vitamin C deficiency in humans results in scurvy. Protein secondary structure is the result of primary structure and hydrogen bonding. We know this. We've proved it. Insulin deficiency in type 1 diabetics results in ketoacidosis. Information is always sourced by intelligent agency, without exception. Life only comes from life. Only the existence of the which path information collapses the wave function. The laws of physics and chemistry contain no symbolic logic functions. Wrong-handed stereoisomers destroy DNA, RNA, and protein secondary structure. We've already proved these. These are validated and confirmed. I could go on for months. My question is there absolute truth? That's my question to you. So, moving on from there, connected with your there's no proof of anything at 1321, here's what you said. I can shoot them up in a rocket to the International Space Station. You can live there, for 3 weeks and come back down, and you'd still believe the Earth is flat because you would be able to explain away everything you saw and heard. Well, that's a begging the question fallacy. There's two of them. Shoot you up in a rocket to the ISS. Go ahead and validate these first, and then we can move from there. I'm not chasing fallacies. Number two, why don't you just have them take one non-CGI picture of the entire Earth from the ISS or any of the fairy tale satellites out there, and we can all go home. No problem. And number three, how on earth would you know what we would do when we observe something? Do you have special futuristic mind powers that you can divine others' responses before they respond? Let's test that. If you do, let's test your blind conjecture acumen here. What's my favorite color? At 1536, you said you can believe in conspiracies and that's fine. Well, thanks. From Merriam-Webster, conspiracy, a secret plan made between two or more or by two or more people to do something harmful or illegal. No, this never happens. Just thousands of times each day, every day, throughout the entire history of the human race. At 1538, you said you can go out into your own backyard with a good quality digital camera, a couple pieces of gear that you can make yourself using a protractor, a cardboard box, a couple pieces of aluminum foil, and you could take careful measurements to determine the shape of the Earth. No, you can't. Please show us. Please post each scientific hypothesis and identify the independent variable, which we talked about before, the cause, in other words, used in your tests, and the dependent variable, your prediction or the effect. I put an FYI in here too. Your eyelids, imagination, and color of the calculator are not viable independent variables. At 1708, You can do all of these experiments in your backyard. You're not doing any experiments. Hello? Measurements and observations without viable scientific hypotheses, red, independent variables, and testing your hypotheses is pseudo-scientific philosophy. It's religion. Observations and measurements aren't tests. Math. Math isn't science or physics, much like a tape measure isn't carpentry. One of the main reasons is they're different words. Math is immaterial and abstract, often rigidly domain-specific, and at best merely describes. It explains exactly squat, nada, niente, nothing. Conversely, actual scientists are in the business of explaining by validating or invalidating cause and effect relationships between independent and dependent variables via rigorous hypothesis testing. This is the scientific method, the main guts of it. That's the whole point about physics. It's not mathematics. He can't say it any more clearly. That's Professor Balakrishnan from ITT Madras. I mean, this shouldn't be confusing here. Let's give an example, and I've done this about 6 times. According to mathematics, there's an infinite set of numbers between 0 and 1. That is, if I started at 0, I can never reach 1. However, whenever I type an I followed by a B with the same finger on my keyboard, I pummel this nonsensical buffoonery every single time. We all do. Therefore, there's somewhat of a difference between the abstract and physical reality. Can you show one case in all of history where mathematics caused any phenomena? Good luck. You'd have better chances resurrecting Alexander the Great's horse. Physics is the physical. It's concrete. Mathematics is immaterial. It's abstract. Is there something wrong here? I would think so. From Professor Shankar up there at Yale, the only way things change in physics is experiments. Everything is based on experiment. It's the only way we change our mind.
Hey, Jay, you got me thinking about something when you talked about mathematically going from 0 to 1, that if you started at 0, you'd never get at 1. I know you and I talked about Zeno's paradox, whereby
that's basically what it is. Yes.
Yeah, and now that I'm listening to what you're saying in response to flat Earth math, that I have to agree. That's absolutely correct. And to add a little bit more to that explanation is this: mathematically, mathematicians, people really hell bent on proving everything with mathematics, have come to the conclusion, the erroneous conclusion, that if you go from 0 to 1, you eventually get to 1. But according to Zeno's paradox, you'll never get there because you're always halfway there. And then when you travel half more of the distance, you're still halfway there. In mathematics, when they come up with these whole numbers to say, yeah, the answer must be 1 or the answer must be greater than 2, what they're saying is this: that the result could be even more finite and more voluminous than we're capable of comprehending. So we're all just going to agree that this one object that traveled from A to B is actually in the same space at the same time in the same position as B, when in reality that's not right. The same object can't occupy the same space at the same time. So yes, when you're using mathematics to try to explain things, they're not using every infinite number of integers and all possible probabilities of what the answer could be. But logically speaking, if the distance between A and B is 100 feet and I travel 50 feet, am I halfway there? Because if I travel another 50 feet, am I really going to occupy the space where B actually is? No, I won't. I'll be somewhere close to it, but how close will I be to it? And that's where the problem lies with mathematics and trying to prove this stuff.
Yeah, and the professor said it straight away. Everyone knows this. I mean, you can't put, you know, fives in a jar and paint it red. I mean, you can't do it. It's abstract. It's not real. I'm not talking down about mathematics. I'm just saying it has a domain. Its domain is to describe. There's nothing wrong with that. It's when you start getting into explanations, it can't do that.
No, you can't. I mean, and again, mathematics was just created to support some sort of definite conclusion or probability. That's all it is. It's a probability. And it's not finite. Because if you really broke down the math, just like James Gates says he did with regard to, finding, code and quantum strings, he can't explain it because he can't comprehend the mathematics that could be more complex than what he's trying to describe. So he had to stop. He stopped. He hasn't advanced on his own theory for over 20 years. And nobody else has, because guess what? They are mathematically inept to come up with any other sort of equation to explain exactly what it is James Gates is claiming that he has seen, but he will never show it. The reason being,
but they can't explain it anyway, because you can't explain it with mathematics. You can describe it.
You can describe it, but you can't, you can't show it. You can't explain it at all.
Exactly right.
And that's where math is coming down. That's why when we asked him, okay, stop talking about it, show us. It's not that he can't show us. And this will sound redundant. He can't show us because there is no math for it, except with what they're using in measurement and linear algebra when they say we need a fixed frame of reference. And we've decided the fixed frame of reference happens to be the Earth that we're standing on, where we have to do anything where we got to go up into the sky to observe and monitor and test and measure. We have to have a fixed frame of reference. If you don't have a fixed frame of reference, you have no idea where anything is, because everything is just constantly moving and dynamic and changing, where you don't have a set position to say, I started here, so let me go around a full circle and come back to this exact spot I came from. If you don't have a fixed starting point, how are you going to know where to come back to? And that's the problem that we're getting here, is that he's going round and round and round and round and round, and nobody knows where he's going to stop at. And
I'm looking for the science. I'm looking for the scientific evidence. They know what I'm going to ask them. I'm going to ask them, what did they observe? Did they observe a phenomenon, or did they observe nouns, which kicks them out of the scientific method immediately? And you know my next question. I want to see the hypothesis. I want to see your independent and dependent, i.e. your prediction. And once I do that, people go through all manner of jumping through hoops.
Well, because here's the thing, like you said, they do not know what an independent variable is. Yep. And if they did, as soon as they go back to their own hypothesis and research question, and then they try to break down what the dependent and independent variable is, and if they've experienced the problems that I experienced last night when you and I were talking, I had the dependent and independent variable, but it had to coincide with answering the hypothesis and research question. I mean, I could be as general as I could be, but if you could come back at me and ask me a question, well, okay, you're saying these mathematical numbers, this quantitative numerical data goes along with your independent and dependent variable, but where'd you get that number from? And then you go back to the hypothesis, you're like, oh, wait a minute, there's no quantitative question to be answered in my hypothesis. So let me reword, adjust, amend my dependent and independent variable, and that's the issue here. They're arguing something that they have no inherent technical comprehension of, and they think that, okay, if I explain it this way, I can only defend this from a logical perspective, but on a scientific perspective, there are too many dependent and independent variables, that I'm unaware of. So I'm just going to throw together some numbers and some math to say it all makes perfect sense. No, it doesn't. It makes no sense
mostly it's incoherent.
It makes no sense whatsoever. And that's where this is going to. They're all trying to prove something they don't understand.
Yeah, the easy way, remember we talked about this last night. The easy way to do it is to ask yourself two questions. The first question is, what am I predicting here? What is my prediction? What am I expecting? That's your dependent variable. The next question is, what is causing that prediction or effect? Those are the two questions you ask yourself. If you can answer those and it's coherent, you have a cause and effect, you're good. You have a scientific hypothesis.
Yeah,
if it's incoherent, you don't.
You have educational professionals like Flat Earth Math who will tell you that the scientific method is talking semantics. But here's the same educational professional going to school every day to educate high school students, and if he believes that the scientific method, that by illustrating the scientific method to get his students to prove and test what it is they believe, he's saying don't get involved in these semantical arguments. Use your logic.
Yeah, that's preposterous.
Use your common sense.
The scientific method is logical.
Yeah, but get this. The irony of this is just coming from the same guy that when I first started talking to him and asked him, and we got into an argument, and I said, what do you believe? What are your senses tell you? He says, my senses tell me the earth is fixed, not moving, and it's flat. But I don't trust my senses. Now, do you see the irony in what he initially said and now what he's actually trying to promote? That the scientific method, the process in of itself, is basically a position of semantics, and it has no application to him actually having the discussion to rebut that what we believe about the Navy railgun and the shape and construct and design of the Earth, if we just use our senses and what he's telling us without showing us the mathematics, that 6.5 million people are just so cognitively aware, and that 100 million or more are just cognitively inept, we're corrupt, we're flawed, something's going wrong with our brain synapses. But he didn't see Robert Shortman's show when we showed a patent on how to actually use Wi-Fi to change your state of consciousness. How about that?
Yeah.
Change your state of consciousness. And we got Mark Diesel in here now. He's muted. He sent me a document. We're going to address that as well, but I'm going to let you finish, John, because he sent me a document regarding the Navy railgun. And again, now this is the first time I'm going to be seeing it. We're all going to be seeing it. We're going to go over it because I want to put that issue to rest. And if there's information in there that might contradict what we had said or correct us, we are all collectively going to agree. We stand corrected. Here's the proper information. And if anybody doesn't want to believe it, that's their choice, man. Go out and do your own damn research, man. I'm not your damn research assistant.
Hey, Robert.
Go ahead, brother.
Can I say something?
Go ahead.
Yeah, I agree 100% with Flat Earth Man.
You got a bad echo, Mark.
I agree 100% with Flat Earth Math.
You agree with Flat Earth Math?
Yeah.
You do?
No, I'm just fucking with you.
I ain't got a problem with it, brother. You know that.
No, I'm just messing with you.
I ain't got a problem with that, man. I ain't got a problem with it. I ain't got a problem with it what anybody believes. Because this is not... For me, it's never been about convincing people, hey, you want to believe the earth is flat? Okay, let me show you some documentation to support you on your beliefs. So you're just not going out there to picnics.
I'm still trying to figure out what I believe.
I'm still trying to figure out as well.
I'm still trying to figure out which beer I like best.
Yeah, I hear you. I'm going to let John finish this, and then we're going to go to that document you sent me, and I got about 3 documents I want to go over as well. Just briefly, we're not going to go over them completely. I got about 1, 2, 3, 4 documents I want to discuss. Just briefly, want to touch on them, and then from there we'll leave a free for all. I think we got like I invited a few people in this private hangout. There's about 2 people viewing. One just dropped out just now as one viewer. They're not commenting. They're just listening. But this is a conversation amongst friends, man, amongst real friends, and I consider the 3 of you real friends, and whoever else is watching out there. So I really appreciate that. And John, go ahead. I'm gonna mute.
Okay, at 1719, you said you can gather a body of data that can point into the direction of flat versus globe. No, you can't. Data is gathered from experiments, which leads to validated or invalidated scientific hypotheses. Too easy. You don't gather data that you or others conjure, then dream up a friggin' fairy tale that fits the observations and the data. For example, you walk into your garage and observe 4 3-foot diameter scorch marks on the wall. That's data. Then conclude that invisible fire-breathing dragons exist. Then call it science. My word, wake up. Oh, okay. You guys are going to be introduced to a treat. My drawing acumen. It is absolutely terrible. I couldn't draw something. I couldn't draw a clue if I had to. All right, let me try this. I'm gonna bring up 2 issues: the dead space issue, and just a brief one on the double slit experiment. So the dead space issue. I think we were both right and both wrong at the same point. I think we were talking over each other. But let's put this one to bed. Let me see if I can draw this good. So, see what I said? Terrible. Okay, you got your weapon firing right here. See, what I was talking about was down here. This is dead space. And it's not a rear slope dead space because there is no slope. These guys are on a flat, it's almost like a depression. These guys are on a flat plane. So this can't hit it, right? Now, you also have dead space over here. And I think this is what Flat Earth Map was talking about, and I understood it, I got it. But listen, this is a forward slope. This is a reverse slope. So the Navy railgun, as documented, can't hit reverse slope targets. And what do we all live on? There's a reverse slope in every direction anywhere you stand on Earth because it's a sphere. Now, it's not pronounced like this, obviously, but conceptually, it's the same concept. This is dead space. This is dead space also. Okay. One last one real quick. We'll do a little double slit experiment real fast. So, like I said, my drawing's horrible.
Dude, if you want me to, I think it would be a good time to show the document Mark gave to support what you're talking about right now, just real quick.
No, let me finish this, Robert. I want to make a point.
What you just described is what literally joins right together with what Mark just sent me.
Do you want to talk about that right now? Is it dead space?
Yeah, it would literally support what you're showing right now.
Okay, Mark, do you want to talk about it?
No, but I just want to say that drawing's just embarrassing, man.
Yeah, it is, isn't it?
No, because I didn't actually. I read a little bit of it. I didn't really dig into it because I'm too lazy.
Right.
So, because I had to go my whole golf cart issue. So, you know.
Yeah, that's outrageous issue. But is there something on dead space that you wanted to discuss?
No, Robert had something.
Let me get the document.
Is this clear?
Yeah.
Like this isn't a reverse slope. This is, you can see this, they're standing on flat ground. This is the reverse, or rear. I'm sorry, it should be rear facing. This is forward facing. There's still dead space in both places. However, this dead space has nothing to do with the rear slope. So,
right.
So I think that irons the issue out. We had talked about that on the video. It's always good to go ahead and illustrate it because talking about it's hard to grasp it. So let me finish up here because I want to get into I want to talk about Newtonian Ferris wheels and roller coasters. Okay, so let's say this is a photon emitter. This could be a photon, electron, atom, molecule emitter. It doesn't matter. They all exhibit this. In fact, the biggest one that I found is 4,500 atomic mass units. Massive. It still does the same thing. So what we're going to do, we're going to fire one, whatever they may be, out of this onto the back plate, right? So what we're going to do first, though, we're going to block up this entrance. We're going to just do a single slit. So what's going to happen is you're going to get a pattern here. So I don't know, say 4 or 5. Okay? Then we're going to block this slit, and we're just going to open up this single slit. What we're going to get over here is more or less the same thing. And remember, we're firing one single piece of quanta at a time. We're going to get this. Now, let me just stop right here. As soon as you had a pixel or a particle hit this back plate right here, guess what happened to Maxwell's theories? They went this direction at light speed. But I digress. So, when we close one slit, we get particles over here. When we close the other slit and leave another aperture open, we get more over here. Okay, they're additive. However, in quantum mechanics, when you open up both slits, you get the problem. You get 0 here. See the problem? That takes Newtonian mechanics, that Ferris wheel riding, roller coaster rolling down to the bottom of the Atlantic. You cannot explain this in Newtonian mechanics. He's done. That's what destroys it. That's what puts the final nail in the coffin, like we were talking about before. Any questions? What I'm saying here is, when you open one window, you get particles here. When you close that window and open this, you get particles here. Now I'm saying when I open up 2 windows, I get nothing here. That's preposterous. But that's what happens every single time. Photons, electrons, atoms, molecules, it makes no difference. So that should square matters away right there. Go ahead, I'm done.
All right. Rob, you got any questions?
No, that was really explained fantastically, and I mean, it cleared it up pretty much.
Can you repeat, John? I could not understand because I'm too late. Sorry. Hello, everybody.
Want to repeat everything from the beginning? Okay, let's go.
Oh, Marcus, man. Oh, Marcus.
Oh, sorry, Robert. I just wanted to add one more thing. I realized Flat Earth Math isn't here. I wasn't doing this, so he wouldn't be able to hear to respond. I think it's good to go ahead and put out my rebuttal and then give him the opportunity, with everyone shutting up, the opportunity to rebut this.
No,
So,
dude, then I will do that in the show. We will give him another invite to come in to rebut this specific video.
Okay.
Private right now. It's just us talking about it. And it was your rebuttal to what he said the first, I think, hour and 50 minutes that you didn't start with us. You came in on like the tail, I think hour 2 or something like that. So
that's correct.
I'll let him know that he'll have a chance to rebut that.
And we can just email him this presentation.
Yeah. So the next thing I want to do is this. There's a few documents that I want to show. We don't need to go over them in detail, but I think that they were important to address because I think we addressed them in the show that we did that day. So what I'm going to do is I'm going to pull these up. And there was one that was actually a prerequisite to the one that I showed. This one's by James Benning from Princeton University. It was resonant excitation of motion perpendicular to galactic planes. Now, I went through this document. Robert Shortman actually and I talked about it. People will talk about the date of research material. If there's been a follow-up study or research done on this particular topic, or it's been referenced in another paper, and they've expanded on it, that's what they do in research papers, people. When they make recommendations or have a conclusion, and they reference this particular paper by this gentleman, James Benning, that means that they talked about something. When you do a literature review, you either are for or against what the person said, or you expand on something that they asked in the research paper to develop an alternative hypothesis, more dependent and independent variables. That's basically what it comes down to. John knows that. So this particular paper in the summary talks about resonant coupling between oscillations perpendicular to the equatorial plane of a galaxy and periodic changes in the force towards the galactic center can cause stars to move from the plane. Okay? Now, people will say to us, you guys don't know how to read documents. You need to go back to school and take English again. Plane means what it means. Flat.
Flat.
Yeah.
Now, you could be talking about the galaxy, but guess what? Even Neil deGrasse Tyson says that the galaxy is flat like a pancake. Now, that doesn't mean that when you get up to the quantum level, it's going to be as flat as a piece of paper. It just means that from a distance, everything is going around in some sort of really rapid circular motion to create flatness, period. When you use a centrifuge, what you're trying to do is separate that specific fluid substance to see what else it could be made of. There must be something else that has more density inside that fluid so that the rest of it separates from one portion to another, and it settles down at the bottom. Now, why does it settle down at the bottom? 1, because of density and mass. 2, because some cylindrical force pushed it there and flattened it out. That's the Earth, people. Not the entire Earth, just part of it, the middle of it. Okay? Then they say the variation of the force to the galactic center may be caused by a non-axis symmetric potential. Okay? But instability is possible even in the asymmetric case. I discussed the circumstances under which these instabilities occur in highly flattened potentials and in nearly spherical systems. Nearly spherical systems. Key words here, people. Key words. Sorry to tell you people out there, there's something we use in research on the undergraduate level all the way through PhD. And beginning from the advent of the computer, where you could go online and search for things, there are things we call keywords. Okay? These are keywords in this document. It's not cherry picking. It's not cognitive dissonance. All right? It's literally reading it word for word. I discussed the circumstances under which these instabilities occur in highly flattening potentials and as nearly spherical systems. This work clarifies the restrictions one may place on the shapes of elliptical galaxies from observations of their nuclear disk. Disk. What's a disk? I never seen a round disk. Has anybody ever seen a round disk out there?
No.
I mean, shit. People who believe in the alien theory know that these spaceships ain't flying balls in the sky. They're shaped like flying flat discs.
Yes.
However, it appears that the most important instability is one experienced by stars that orbit at large radii in the disk of a galaxy which has a rotating central bar. Any barred galaxy will have an analysis of such stars. Complete analysis of the importance of this just skip my space, damn. Of this analysis requires that the theory of this paper be extended to include the disk self-gravity. But the mechanism discussed here may help us understand warps and congregations in the gaseous disk of galaxies, the kinetics of stars in the solar neighborhood, and the sharp edges possessed by many stellar disks. Now, I'm not going to go through this whole paper, but I found some interesting things that they discussed in here, which this is sort of a precursor to what we're going to be discussing in the future. We're still doing the research to interpret the data. Okay, that's a lot. That's a lot of what's not going on with people who are putting out videos. There's maybe, I would say, a handful of people out there who can really interpret the data. They know who they are. All right. Bob Nodal can interpret the data. All right. I know Jaron has learned how to interpret the data. Brian Mullen definitely can interpret the data. Dr. Zach can definitely interpret the data. Who else is there out there? There are a few other people out there who really, I think with the GeoShifter, he can interpret. There's a lot of people out there. All of us, we can interpret the data. We put in the effort to interpret the data to find out what does this mean. But there are people who just run with this stuff, or they don't even look at it at all and care because they don't want to go through the effort to interpret the data. Okay? Again, this was the precursor to that one document I showed. A lot of mathematics in here. I'm not going to get bogged down by that right now. Hold on here for a second. There was a specific section. Robert and I actually talked about it. This is scatter plot chart. Closed orbits and rotating triaxial potentials. Again, I'm still going over a lot of this data. Orbits and model potential. Hey, where was that one? I think was it the other document, huh, Robert?
Yep.
And again, here goes the equations to nearly spherical systems. My question to Flat Earth Math, man, you teach in high school mathematics. Why are you not doing this stuff? Why can't you show us what you're trying to tell us by doing the math? He definitely understands it, but why not show it? Goes back to what John was saying. Hold on here for a second. I'm not sure if this might be the document. This was the precursor to that document. Yeah, and there go your references here. No, that wasn't it. It's this one. Motion of a sphere in the presence of a plane interface. Now, where was it at? Zane Holloway sent this to me, man. Dude is really into the science. Really, really into this. This dude works hard. But when he finds this stuff and he sends it to me, I know he's gone over it. I'm still trying to get him on, too, to talk about this. Because he loves reading this. Because I talked about this with Flat Earth Math when I said to him, when I read this to him, that the paper presented represents an exact solution in bipolar coordinates from the motion of a sphere near a fluid-fluid interface. And when I think what I explained to him was that, do you believe what is below is above? Meaning, we got water below us. Do you believe there's water above us? He said no. He said no. He says no. There's no water. There's no oceans above us. That's preposterous. Okay. Do you believe it rains? Yeah, I do. So where did the water come from? And then I think that's when you came in. He's saying, he don't know how it's happening. But this paper describes it. This paper describes it. Bipolar coordinates from the motion of a sphere near a fluid-fluid interface. He didn't want to accept this at all. They said the third part of the study, part 3, is concerned with the interface deformation. We consider two cases. All right? Here goes your dependent and independent variables. Okay? That in which the final steady-state deformation is small and calculable using the velocity and pressure fields generated in parts 1, 2, and 2, where the interface deformation is not small. In the latter case, a numerical solution of the complete problem is required to determine the velocity and pressure fields. Everybody keeps talking about gravity. They keep talking about pressure. Look at here. All that is required is the distribution of singularities for motion of the same particle in an infinite fluid. Now, you guys that are on the panel, what fluid have I been pushing as the fluid that may be up in the upper atmosphere? It sure as hell ain't just sodium. I've been pushing superfluid helium at absolute zero. Zero viscosity. Zero viscosity. When we talk about how vast space may be, knowing where it starts, if it ends at the Kármán line, 328,082 feet, everything from, I'd say, the upper stratosphere on up, that's how vast space would be. That's huge. I mean, that's more than the landmass on the Earth, right? But if you can't measure this, John, am I correct to say that they always use this term infinite fluid? They always use infinite when they can't clearly measure how voluminous something can be, where it starts and where it ends? They always use that term, infinite.
There's no such thing in reality
As infinite.
as infinite.
There you go. But they use this term because what they're saying to you is they can't measure it. We just didn't have the technological capability to say, okay, singularities for motion of the same particle in and whatever amount of space. They have to say infinite fluid. They don't know what the volume of it is. Basic equations. I gotta look at one section Robert Shortman and I actually talked about, which is going to lead up to let people know what it is we're going to be uncovering. And I'm going to let this cat is definitely coming out of this paper bag. And we're going to be the ones to prove it too.
Hey, Robert.
What?
Hey, they also conjure singularities by dividing by 0 and saying there's infinite density.
Yeah. The 0 is just a common number.
Well, how can you get to a singularity then?
You can't.
Then there's no such thing.
Exactly.
There is no such thing. They're hoping there is.
This is what kills me about this bullshit, is they tell you one thing and then explain something in a complete opposite manner.
Okay, so this is important, and the reason why I say this is important because I'm all about numbers, and that's how I kind of got my start. You know, after high school, working down on Wall Street, I was just really, I don't know. You guys ever seen that movie? What is it? A Beautiful Mind? That guy was always, he just drove him crazy. He drove himself crazy, man, just doing numbers on a blackboard and shit. Like went to go work for the NSA to do code breaking. But get this. What caught me was this equation. But look what they say is the follow-up. They say it is clearly evident that the fluid motion in both fluids is retarded as the viscosity of the upper fluid increases. Is that not what you had talked about the other day, John, with regard to entropy?
I don't know. I'm going to have to take a look. I haven't looked at this paper.
About how he was talking about the pressure changing, if you put a rubber hose and all that nonsense.
Now, listen. Entropy between liquids and gases is as far away as the cell membrane of eucalyptus trees and orangutan.
Well, in this particular case, here's what they discuss. They go on to say that the stream function for A, right, and then the angle equals 0 times 0.11 or 100, or compared with the stream flow for an unbounded single fluid. And then they conclude by saying it's clearly evident that the fluid motions between both fluids is retarded as the viscosity of the upper fluid increases. So if you've got your lower level, sea level fluid, you got your gases in the middle, right? You got your gases in the middle. Then you have maybe some sort of zero viscosity layer in the atmosphere. And then, but you got a heavier density of something that you just can't describe. Let's say it was the sodium atoms, right? They're saying that area above, which is losing, we can't say it's the upper fluid is increasing. Okay? So could there be a layer of atmosphere when we talk about barometric pressure where the clouds go over and then all of a sudden it just starts shit pouring rain everywhere? I mean, it just rains so hard to where I think that what they're describing here is that you get two fluid environments moving together with each other and they start to slow down. The upper layer of atmosphere creating these storm and storm clouds just opens up the sky, and there you have your water, your rain. I've had to read through this a little bit more. I'm guessing. I ain't going to deny that. I'm guessing on this. But it describes how it's happening. based on these equations, the motion of a sphere near a plane surface. Where do we see? The motion of a sphere known to a plane fluid interface. Hang on for a second. I'm hoping that damn document was in here. Hang on for a second. Because it actually discussed. Let me see here. I wonder if this was it. Rotation of a sphere in the presence of an interface. Finally, we turn to the case of stationary sphere rotating with a constant angular velocity y in the presence of a plane surface. Y is non-dimensionalized with respect to UC over LC. The solution of an infinite fluid can be simply represented by a rodlet at the center of a sphere, and the velocity field generated by a rodlet is given by equation 6.1. Thus, the zeroth order solution for a rotating sphere in the presence of a plane surface. Dude, this is flat earth mathematics, man. No, and I'm not saying that it's reference to flat earth math either. This is flat earth mathematics. You want to explain how the earth is moving? And I don't mean the whole earth. I'm talking about the atmosphere. Here it is, right here.
Well, they've worked it out for flat
Yeah,
earth mathematics.
they've worked it out.
Just relabeled it something different.
Yeah,
Or-
they put fluid dynamics, you know, into this whole thing in linear algebra. Thermal equilibrium. Thermodynamics. To cancel this additional velocity field sphere, the rodlet is needed at the center of the sphere. Hang on for a second. I haven't had a chance to go over this entire paper. I already haven't. I'm not sure if that was the one, but let me see something here. Oh, of course I was looking at the wrong document the whole time. It's the detection of the ether. We're in Kansas, baby. We're in Kansas. Hold on. Let me see here. I think this was it, wasn't it, Robert?
Yep, detection of the ether by Webster.
This was it.
Yep.
Let me go back big again. This is where they talked about that lunar thing. Okay, here's where we're going to go. Let me see if I can find this. It was chapter 10, right?
Yeah, just scrolling down now.
Chapter 7.
I seen the cosmic microwave background radiation. I'll take that to the woodshed at another time.
Yeah, we'll do that. It was chapter 10. Wasn't it, Robert?
Yeah, I'm just checking now. It's definitely.
Major problem. First major paradox in the book. Chapter 9. Okay. Let's keep going. One mirror simplified. Hang on. It's chapter 10, people, so I'm getting there right now. Okay, here we go. This is it. So, what we will be reviewing at a time of my fucking choosing will be the exact distance of the moon from the Earth. Now, will it be a 2016 measurement? Probably not. But we've got the data. We've got the numerical data from several different lunar laser ranging tests that were conducted from 4 different observatories on Earth. I think 2 of them were in the United States and 3 are in Europe, right?
Yeah,
Right,
correct.
Robert?
Yep.
Right?
Yep.
3 in Europe, yeah. So 3 in Europe.
Yep.
And we have their data, and they show us how to read it, how to interpret it. I'm not going to say what the information is we're trying to decipher, but there's one specific measurement we're going to need to test ourselves to determine if we could duplicate it, just one set of numbers, we're going to know exactly how far the moon actually was lasered. And the time frame goes back, I think, 10 years or something like that? 10, 12 years?
Yep.
regardless of the time frame of when they lasered the moon, and they lasered it several times just in one damn day, 1 month. And they said that they had the Apollo missions drop there's a mirror, there's a reflective mirror they say is on the surface of the moon. They don't even tell you the location of where it's at. How about them apples?
Hey, Robert.
Yeah.
That's not the first time that it was done. Where they claimed that they shot a laser off the moon. I have it right here.
Well, they didn't.
It was in 1962 by MIT.
Okay.
I'm going to put this in the group chat. Go on.
Yeah, I'll pull it up.
Yeah,
The problem I had is that they don't say where the actual mirror is. They won't tell you. None of the documents I read so far won't tell you where the mirror is located. But get this.
There too.
Yeah, it's about the size of a 55-inch fucking flat screen television. Supposedly. Supposedly, it's about the size of a 55-inch flat screen television, but it's a round disc. It's a reflective mirror. They say that they left there from the Apollo missions so that they can always laser shoot the moon to know how far it was from the Earth. Okay?
Hey, Robert, I put that in the chat.
Okay. And we were talking about this. I talked with John about this. I talked to Marcus about this. I talked to Robert about this. And what they describe in this document on how big the laser beam was by the time it got to, let's just say for argument's sake, if we go with them and say the moon is average between 230 to 250,000 miles from the Earth, the size of that laser, by the time it got that distance,
Yes, would be like the moon.
yeah, they actually say in their own document that they missed it a few times. Right, Robert?
Yeah.
They say that, hey, we lasered and we missed it. So,
Yes.
but then one time they say that, they hit it right square on. All right? And then they blame the inaccuracy because by the time they shot the laser and the light came back, the reflection came back, the moon had moved 40 kilometers or something, rotated 40 kilometers. That's a bunch of bullshit. Because if the moon actually rotated, you tell me how come every time I see it up in the nighttime sky with a pair of binoculars, I see the same goddamn fucking craters I've always fucking seen all my life.
Yeah, that don't work.
And I can stand there and watch it fly across the nighttime sky, and I still see the same fucking side of the moon. So that was a bunch of nonsense. But we went over this just a little bit. We're still going over it. And we got the data. And what they described, this guy in this document, he went on probably for about 10 pages talking about the exit mirror at 15 degrees away from the point of origin. Okay, where's the point of origin? Okay? Why you going to throw in 15 degrees? You don't tell me where the origin's at. All right? He goes on and on and on and on. He says there are 5 retroreflectors placed on the moon between 1969 and 1973, but only 4 of them are functional. The largest of these retroreflectors, and the one most often used in LLR experiments, was left by the Apollo 15 astronauts in 1971. Retroreflectors are generally about the size of a small suitcase. So there you go. I said it was about the size of maybe 55-inch television. Well, maybe smaller than that, maybe 40 inches, 34, 35-inch, right? That's how big it is. And they're saying they're hitting. Now I'm not a laser experiment. I don't know much about lasers. Marcus just shared some information with me regarding calculating out what the power output would need to be for a laser, the color of that laser, because they say in these documents they're either shooting 1 or 2. 1 stands for green lasers, 2 is infrared. Okay? Now,
I just put the document in the chat. You can read from the Technical University from Munich.
Yeah, let me pull that up real quick here. Sorry about that, guys. My apologies. Oh man, don't do this to me right now. The one you just put up, Marcus? Or John?
Yeah,
No, I.
Yeah, Marcus has just popped in.
Okay, I'll put up Marcus. So here is the high precision measurement of Earth-Moon distance. Okay, they go through the measurement process. During the Apollo missions 11, 14, and 15, the astronauts being placing retroreflector arrays on the lunar surface. Okay, the Russians on that deployed reflectors array 2. One failed completely, probably due to covered by dust, and the other one seems to be less efficient than the Apollo reflectors. Okay. So here's what they say. Short laser pulses, microseconds, duration in the beginnings to about 100 picoseconds nowadays. Now, Robert, John, I'll let Robert go first, and then I'll let John go. Explain for our audience how fast a microsecond is and how fast a picosecond is.
Yeah,
Go for it, Robert.
Picosecond, they're pretty quick.
1 picosecond is how many years, Robert?
1 picosecond is about 37,000 years.
1 picosecond is 37,000 years.
Yeah, no, sorry,
What?
31,710 years.
1 picosecond. That's how long it takes. Okay?
One picosecond is 1 trillionth of a second.
1 trillionth of a second. Robert converted to years is 31,000 plus years. Okay? Now,
I think it's 1 picosecond to 1 second is as 1 second is to 30,000 years. Is that correct, Robert?
Yes. Yes.
So that's what they're saying. Now, the measurements that we've collected say that those numbers coincide with 1/10 of a picosecond. Now, one of the numbers we reviewed was, I mean, literally, it wasn't even a picosecond. It was a tenth. It was like 10/100ths of a picosecond.
And that's such a small amount. I mean, if I'm looking now, you know, it says a 3 gig common computer at 3 gigahertz CPU. It would take probably 330 picoseconds to add 2 integers.
There you go. How many picoseconds for a computer?
330 for a
330 picoseconds to calculate.
For a standard 3 gig computer, 2 integers.
2 integers.
Yeah.
That's just to calculate 2 integers on your standard computer. So when they say that they can shoot a laser from the Earth to the moon and it comes back in 10/100ths of a picosecond, all we have to say to you guys is better start thinking about how fucking far you think the moon really is. Or how close it really is.
Yes.
Yeah.
But let me continue reading here what Marcus put up. And then they say, counting the round-trip travel time of the laser's pulse directly gives the distance by multiplication, half of it, with the well-defined speed of the light. Now let's shed some light. Let me close this, people. People don't know how to get the message. Okay. Now let's shed some light on the very special conditions which make lunar laser ranging much more difficult than laser ranging to satellites. A single laser pulse may consist of almost 10 to the 18 photons within a length of about 3 centimeters, full width, half maximum, when leaving the transmit telescope. The pulse length directly defines the achievable accuracy of the measurement. YAG solid state laser may deliver 10 such pulses per second, each carrying the energy of some 100 millijoules, corresponding to more than 1 gigawatt of pulse power, but only for a short time of, what is that? 1 billionth of a second. 1 billionth of a second. During his journey to the moon and back 2 times, 380,000 kilometers within about 2 to 5 seconds. All right? The laser pulse encounters a lot of inconveniences which diminish significantly its strength. Now, they're admitting here, there ain't no way they're finding some high energy pulse, 380 kilometers to the moon, and it's taking 2.5 seconds to come back. They can only fire it twice. 2 times, it comes back in 2.5 seconds. But the picosecond is what we are concerned with, because that tells us distance. This doesn't. If you're going to say find 380,000 miles is 2.5 seconds. That's a standard number they want you to believe. Based on distance, they want to tell you this is how far the moon really is. That's bullshit. That's not how far the moon really is.
Hey, Robert, you got another problem. If they're using the speed of light, right?
Yeah.
There's another problem. That's a begging the question fallacy, because the speed of light is the average two-way speed. You can't calculate the one-way speed of light. It's a begging the question fallacy. If we need to go into that at some point, we can. Hey, Robert, you still there?
Yeah, I'm here. I got invaded by the minions.
Hey guys. Hey, I gotta get going, so I'll talk to you.
Okay.
Hey,
All
we'll
right.
catch up to you later, Mark.
All right.
So again,
Bye.
we go through this, and they say during this journey, yada yada, atmosphere, forth and back, one-way extinction factor by 0.1 to a half. Arriving at the moon, the laser pulse has a diameter of more than 5 kilometers. Now, here you go. The reflective mirror is the size of a suitcase, but the actual diameter of the laser, when it hits that, is 5 kilometers. 5 kilometers.
Yes.
My thing is this: how big is that laser when it leaves that laser rangefinder? How big is it? I think what did they say how big it was? Didn't they say it was 3 centimeters? 3 centimeters.
Wait,
This is
what
impossible.
are they saying? Wait a second. Are they saying that they're shooting 238,000 miles with light diverging only 5 kilometers?
Only 5 kilometers.
Yeah.
You ain't hitting nothing the size of a suitcase. You are not hitting anything the size of a suitcase at 380,000 kilometers, bro. And it's supposed to be 5 kilometers wide. They said only a very small portion corresponds to less than 1 square meter is being reflected back by the reflector array. So they're saying they can only... Come on, man. A suitcase is not fucking 1 damn square meter. How big is that suitcase? I'm sorry. You guys carry suitcases on planes, right?
Yeah.
You
Yes.
put them in the cargo, right? Hey,
Yes.
does anybody in this conversation own a suitcase the size 1 square meter?
No.
You do. I want to
No.
know where you bought it. Where did you buy it? Where did you buy that suitcase? Do you see how we just used their? Do you see how we just used their own information? I'm not saying we debunked this. We didn't. We didn't debunk this. But do you see how that information doesn't make any damn sense?
Yeah, no one owns
They
a suitcase
said
that size.
the array is the size of a fucking suitcase.
Yeah, that's stupid.
I know I read that. Did I not read that?
Robert, why did they need that anyway? Because they reflected a laser off the moon, according to them, in 1962. MIT did. You can pull that document up after you're done here.
Well, yeah, that moon was definitely really close. That's the only way MIT would have did it. I mean, this is definitely information I'm going to be saving. We're going to be going over, but I just wanted to briefly. They talk about the echoes. Yeah, I don't even know what this stuff is here. I gotta still go through this. Evaluation of measurement distances. They love throwing Einstein's name in there with everybody else's fucking name. Einstein, Infeld, and Hoffman.
It's a German university. They have to.
Ah, shit. This is crazy. General theory of relativity. I mean, no, John's gonna rip this apart.
Oh, goodness.
I already know, dude. Don't even go there right now. Don't even go there right now. Because it's another fucking 8 hours, dude, if you did that. It's another 8 hours. So, going back to this document, detection of the ether. We're going to discuss this. These are going to be in future shows. This guy goes through probably about another 10 pages talking about nothing. He does not end up telling you exactly where the moon was, the distance. He gives you an examples, okay, but he never tells you. All he says here, a laser beam is shot at the moon in retroreflector, okay? During the time it takes this laser beam to travel to the moon and back, about 2.5 seconds, we already saw that they agree on that, both the Earth and the moon as part of the solar system move about 948 kilometers towards Leo. Man, do you see how deceptive that just was? He don't want to tell you where Leo is. He just says Leo is 474 kilometers while the beam is headed to the moon and 470 kilometers while the beam is headed back to Earth. John, do you know where Leo is?
Nope.
Robert, do you know where Leo is?
I don't know.
Marcus, do you know where Leo is?
36,000 kilometers.
From where? Your house?
I don't
Your
know.
house? If that's the case, Marcus, you almost right here in Colombia, man. I mean, come on, man. This is how.
Yeah, I have to look.
I mean, you
know.
can tell that he was struggling. Oh shit, I can't tell him exactly. This 948 kilometers, I can't tell him it's from the Earth. I can't tell him that this distance is actually probably the distance how far the moon was from the Earth. Instead, he says 948 kilometers towards Leo. Then he says because the returning beam is only 20 kilometers wide when it returns. Whoa, wait a minute. You hit the damn reflector array on the moon 380 kilometers away. It was 5 kilometers wide to hit a fucking suitcase 1 square meter big, and the beam came back 4 times bigger than what it was when it hit the moon. So think about this. All of that light coming reflecting back through 4 layers of gaseous pressurized atmosphere. You really think they got that distance correct? Because it's got to go through a shitload of atmosphere, right?
Yeah, huge amount.
So Leo is between 200 and 2,000 kilometers, no?
That's what
Correct?
they're saying. So reading this, is the moon really 380,000 kilometers?
No.
Looking at this,
Of course not.
Of course not. Then the guy says, then the return laser beam should miss the telescope. That the shot laser beam by at least, it overshot the laser beam by 928 kilometers. This is because both the Earth and Moon have moved 948 kilometers towards Leo while the laser beam was in the air. Wait a minute. What the fuck? I'm sorry, man. I'm sorry. Wait, and you're telling me in 2.5 seconds, the Earth and the Moon fucking moved 20 kilometers.
No.
Man, dude, that ain't no real moon. That's some fucking body playing hide and seek in a costume that looks like the moon. Come on, dude. I mean, really?
Yeah.
They're saying the Earth and Moon moved 940 kilometers towards Leo. Marcus says that distance is over 2,000 kilometers. Dude, how fast is the fucking moon moving?
Yeah.
Dude, that's a fast fucking moon. That is super fast, which means that if the moon is moving at 948 kilometers towards Leo, that means we should see the moon twice in one fucking day. No, 3 times in one day. You should be seeing the moon 3 times in one day. Just in the same spot you're in right now.
Yeah.
Marcus, you should see the moon 3 times. Robert, you should see the moon 3 times. John, you definitely should see the moon 3 times. Dude, there's been weeks I ain't fucking seen the moon. So where does that leave me? On another planet?
It means that they're just lying with all the data and.
Dude, this is crazy, man. This is from Kansas. He keeps talking and going through this document, never telling you what the conclusion was. And then when he threw in this here about 1/10 of an arc second, I'm like, okay, the math is just really screwed up now. He says here, hitting the retroreflector and looking at old light. Now let's get down to the details.
This
When a
is
telescope,
preposterous.
John, don't go there. I know, dude. I ain't trying to set your fire off right now, bro. When a telescope is looking at a galaxy 100 million light years away, you guys saw my perspective video. I showed you what 100 million light years looks like. There ain't shit out between us and 100 light years. There ain't nothing out there. He says it is looking at the light that left the galaxy 100 million years ago. They're saying we have the technological capability to see something 100 million years ago. Okay, I want to see my damn monkey gorilla ass relatives get together and decide we're going to give birth to Robert BASSANO 100 million years from now. Dude, they're saying we can look at star light 100 million years ago, right? But you're telling me I live on a ball and I can't see 20 fucking feet, 20 miles.
Yes, and Anna Nicole married for love, and Pol Pot was her florist.
Well, you can see it when you watch a plane. You know, this is 10,000 meters, for example. You can imagine after the 10,000 what is coming. The plane will be even smaller. You cannot see fucking 20 kilometers, yeah?
Yeah.
He says here, it is also looking at where the galaxy was located in the sky, ignoring aberration, etc. 100 million years ago. The same holds true when a telescope is pointed at the moon. When an optical telescope is pointed at the moon, because it takes 1.25 seconds for moonlight to get to the Earth. Wait, make up your fucking mind. I thought you said it was 2.5 seconds. Now you're saying it's almost half the time for the light from the moon to get to the Earth. The telescope is really looking at where the moon was located approximately 1.25 seconds earlier. Oh, here we go. So the moon ain't even real, dude. The moon not real. That means that when you see the light from the moon, that's where it used to be. It actually was 1.25 seconds, 948 kilometers away from Leo. So in 2.5 seconds, the moon traveled 948 kilometers from Leo. So where you thought you saw it last night, John, go back 948 kilometers. That's where it really was. That's what they're saying. Now,
Or maybe a satellite.
Dude, I'm looking forward to the comments of people saying, Robert's a dumbass. He can't even read the data properly. He doesn't even understand what he's reading. Neither do you. Because it's in plain English here. And the only person whose first language ain't English is Marcus, and Marcus understands this.
Yes.
So how you like that? Behind where the moon is actually located, when the light arrives at the telescope, this is based on the assumption that the Earth and moon are headed nose to nose towards Leo at 370, what? kps, that's kilometers per second. Whoa. Whoa. That is kilometers per second, right? How fast is 370 kilometers per second in miles? Miles per hour, Jay. What does that come out to be?
I'll have a look.
KPS is kilometer. They're saying that they're assuming that the Earth and Moon are headed nose to nose towards Leo at 370 kilometers a second.
827 miles per
So
hour.
that's how fast the Moon is moving, right? 827. Oh.
This is 370 meters per second, no?
No. To do kilometers per second.
Kilometer. 1 second.
Kilometers into miles.
It's
Yeah.
827,666
Miles?
Yes.
miles per hour.
Correct.
You got to be kidding me, dude.
No, that's what the
Seriously,
conversion is.
I can't. No joking around, bro. Is that real?
Yeah,
Yes.
370 kilometers per second equals 827,666 miles per hour.
Okay. I gotta do
4.280.
something real quick
Yeah.
here. I gotta do something real quick here. Okay. KPS convert to MPH. I just need to make sure because I don't want to get punked on this one. So, kilometers per second. 370. Holy shit. 827,000 miles an hour. Golly. Man, have I lost my damn mind?
The only thing that's traveling that fast is their imagination.
You're right there, Johnny.
This is crazy, man. But again, in all fairness, I want to say that this guy is making an assumption. He's supposed to be a scientist, right? He's supposed to be a researcher. He says that these speeds, that the light from the moon is really light that's 1.125 seconds old. That's what he's saying. The light from the moon is 1.25 seconds old. And that based on assumptions, which he probably got from his other delusional colleagues to put this paper together called Detection of the Ether, he's saying we are assuming that the Earth and Moon are headed nose to nose in a neck-and-neck race. Who's going to win? Towards Leo at 827,000 miles an hour.
According to mathematics, the moon should never catch up to the Earth.
That's what everybody's been saying, huh? That's what everybody's been saying. He says, in other words, the light the optical telescope is seeing is old light, meaning that by the time the lunar light arrives at the telescope, the moon has traveled 474 kilometers. Meaning the telescope is constantly looking 474 kilometers behind where the moon is when the light arrives.
So the moon is a Fata Morgana.
Dude, this is crazy. Hey, listen, am I getting a little bit melodramatic here, guys?
No, because it's a reviewed paper that they're hardly going to make a mistake in it, are they?
Well, that's what they claim. They're not going to make a mistake.
I need this document for a new video.
Well, I'm gonna give it to you too, Marcus. I got it. Dude, this is crazy. So that means if I pulled out a pair of binoculars tonight and the moon comes up, and I tell my son, Nico, look, la luna, and I look inside the binoculars, if it takes me 1.25 seconds to look at the light of the moon, by the time I look at it, it's already 474 kilometers away. I'm looking at old light. I'm looking at a hologram. I think this is what people are talking about.
Right.
Now, this is probably supporting what people are saying, that the moon is actually
a simulation.
Yeah.
Dude, that's crazy.
Could be.
Could
Dude,
be, huh?
This is crazy. That could be. Come on, Robert. I mean, really?
Yeah.
I know you're a hard guy to convince, but really.
Yes.
I know you were hard.
I'm melting now, kind of thing with this. There's not much convincing needed, really.
Oh, but get it. You must be listening to us because I think the language changed while we were reading. It gets worse. That's what he says. It gets worse. Because in the time it takes the laser beam to get to the moon has moved an additional 474 kilometers. Oh, shit. This means that the laser beam, which is only 7 kilometers wide when it gets to the moon. Whoa, wait a minute. Oh, dude, this dude just fucked up. Did he not say, wait, he didn't screw up. He must not got the memo from Marcus. He didn't get the memo from Marcus. Because Marcus, I know, sent him this email. Right, Marcus? You sent him this.
Yes, of course.
He didn't listen to your German colleagues, okay, when they said the laser beam has a diameter of more than 5 kilometers. Okay, I'll be fair. They say 5 kilometers. This guy is saying the laser is 7 kilometers wide. So it's about 2 kilometers more. But the Germans did say it's more than 5. They just maybe they didn't get the memo in time before this guy did his paper.
Okay.
He says they'll miss the retroreflector by 948 kilometers. So you missed it. Why did you miss it? I'll tell you why you missed it at 948 kilometers. Because you're trying to hit something the size of a fucking suitcase. that you claim is fucking a square meter fucking big. If anybody out there has a suitcase 1 square meter in size, please tell me where you bought it. I need one. Because I'm
Who
tired of
cleaned the
packing.
dust up? Who cleaned the dust up from this fucking thing? Yeah.
Yeah, and that's what's so funny about it. The Russians sent something up there, and somehow somebody kicked a bunch of fucking dust on theirs. But NASA's reflectors happen to be clean as it can be.
Yes.
So
USA.
yeah, so they got some sort of moon janitor up there cleaning house. Okay. Then he says to explain the telescope, the laser is pointed, aimed 474 kilometers behind the retroflector is located because of old light when it fires a laser. I'll go with that. You got to point 474 kilometers because by the time the laser is shot, it's already traveled for it. John, does that not what we all refer to in the military as leading the target? Huh?
Robert, you lost me way back when you said theory of relativity. We're just whistling past the graveyard down this document.
They're leading the target, man, hoping they're going to hit it.
Rob, I'm with you, John. I'm with you. Don't worry.
Oh my God.
But I take it in consideration.
I can't read any more of this. This is sickening.
Please, thank you.
This is sickening. I mean, we're going to go over it again, but when we do it, we're going to be the only ones on YouTube and in the flat earth to have the proof and the documentation to show you the fucking moon is not at 380,000 kilometers. We're going to prove it.
It's true. Yeah.
We're going to prove it. We're going to show you. This is just a taste of one of the documents. And it's a big damn document, too. It's 164 pages. And I ain't sharing it with anybody but the 4 people who are actually on this panel right now. If you want to go find it yourself, because I ain't doing your homework for you no more. You're just going to have to wait. So, the next thing I wanted to show somebody that we're going to talk about and electronic properties of nanodiamonds. Everybody thought I was crazy to say, oh, first you want to say there's sodium atoms, then you want to say it's superfluid heating, and now you want to say it's fucking diamonds. It could be all of that shit up there. It could be all of that at different layers. At different layers. I'll give you guys a little taste of this. Let you see it. Bonafide research paper. Got a lot of haters out there, man. They don't like the documentation, John. They don't like it, man. Sources of that. Nanodiamonds in and from outer space. Woo! Robert ain't crazy after all, huh? And then you got Flat Earth Math not wanting to admit that there's atmospheric particle scattering.
A huge amount of that.
To disperse the light from the sun or in the atmosphere. That's what he said. If he didn't say that, he's going to have a chance to correct himself. Another document we're going to show. Okay? We're going to talk about this. We're going to go over all the data. But we're going to be the 4 of us. Robert Shortman, John, Marcus, my boy Mark Diesel, and me. We're going to be the ones to show you guys the proof of where the moon is. Proof. I'm not going to tell you when. It's going to be a time of my choosing. You can watch or you can't watch. You can have your own personal hang-ups. I don't care.
I'll tell you what. It's not a sphere because it's reflecting light uniformly. So
I don't care if it's shaped like a damn dog shit. It ain't where they say it is. I don't care what the shape is anymore. Nothing is what they say it is. Nothing. It's not where they say it is. It's not functioning the way they say it is. And here we go showing the documentation as we go through it together as a team and realize, whoa, wait a minute here. You guys are supposed to all be working together. How the hell one of you say something in Europe and the other one contradicts what the other one says in the U.S.? Make up your damn mind. You guys spending all this damn taxpayer dollars, you know, putting out all this information you don't want people to interpret. And then you get caught. Nanodiamonds in oil. How about that? How do you spell diamondoids? That's a new term. Diamondoids. Nano diamonds and oil. Now that's going to be a good show, John, because think about this. Now you see the importance of how oil probably ain't worth shit. They're actually looking for the nano diamonds inside the oil. And when they go through the refining process, John, that's what gives us its fucking value. The actual crude itself ain't worth shit. It's the refining that takes place where they extract the nano diamonds from the oil. There goes your value right there. That's why crude goes up and down. But the price of diamonds don't. The price of diamonds and gold, it fluctuates the way it does, but they're two of the most valuable substances on earth. And they're found in abundance. This is an entire show right here. This damn document right here. Structural properties of nano diamonds. We're going to break this down. We're going to break this down. For sure. Guys, I'm going to put this in the cloud so all of you can have access to this stuff. Marcus, for sure, I'm going to share this with you. And we'll go from there. But it's interesting, man.
Hey, you forgot to pull up that MIT document. I haven't read that in a while. Can you pull that one up?
Okay. Hang on a second.
Go over that. It should be short.
It's crazy, man. I can't believe what we were just reading. Actually, I do believe it. I do believe it. They actually believe we are that damn ignorant. No, they really believe we're that damn stupid. Can you see the MIT document?
Flatheads.
Can you see it, John?
Yes.
Okay.
Go ahead, blow it up and read that little bit of it, Robert.
May 9th, 1962. I wasn't even a tickle in my daddy's pants, man. Louis Mullen and Giorgio Fiacco of the Massachusetts Institute of Technology aimed a ruby laser beam toward the moon's surface, and Albigenus became the first lunar feature to reflect laser light from Earth. How about that? Last night, for the first time, man illuminated another celestial body. Had someone been standing in the mountainous region southwest of the crater Albigenus on the moon, the stark and darkened lunar landscape about him would have been lighted by a succession of dim red flashes. The effect is thought to have been limited to a circular area of the moon's surface, only 1 mile in radius. The light beam was produced by engineers from MIT using a device known as a laser or optical maser. It produces a beam of extremely intensity and narrowness. The reflected light could be detected on Earth only by electronic means. Okay, 1962, huh? What was the electronic device? He and many others believe such devices will play a key role in communications with and between space vehicles. They could be used to provide power to expeditions on the moon or other planets using sources on the Earth. It's also being tested as a surgical knife and may be useful for delicate welding jobs. You believe we had this technological capability? There was no disc. They said they shot this right at the surface. There was nothing there.
I don't believe.
There was nothing to reflect off of.
Yeah. It's just going to hit the object.
I mean, they don't even say how big this thing was.
Yeah. That's incredible.
It had to be huge, dude.
It would have to be a massive laser to cover that size of that crater. How big do they say that crater is then?
They said it was 1 mile radius.
Wow.
Yeah. Yeah, we didn't have this capability in 1962. I don't believe it.
Not lasers that distance.
So the
No.
first laser was built, I just looked on, the first laser was built in 1960.
This is 2 years after they've designed the laser, the first laser.
Yeah, it's impossible.
Yeah, they couldn't have did this. But we're going to check it out. What does this say? Early post on lasers. 1960. The first working laser. So you're telling me 2 years later they said, fuck it, let's just shoot it at the moon.
Yes.
Fuck it, let's just shoot it at the moon. But see, they shot this late. You got MIT shooting it at the moon. What was the distance? They don't you see? You see? they put this little image on the moon, right? 1 mile, one square mile, right, in diameter, with
No suitcases.
no suitcases. There was nothing to reflect off of.
No, nothing.
Yeah, yeah. And the moon's 380,000 kilometers, right? Yeah. Uh-huh. Uh-huh.
IS.
Yep. And I dreamt I was a 1,500-foot giant. I dreamt I was a
They
1,500-foot
reported
giant.
today Jimmy Hoffa was Cinderella.
I was a 1,500-foot giant, and I was shitting giant trees. Yep. I was a 1,500 vegetarian giant shitting trees and drinking wheatgrass. The grass was 300 feet tall.
Yeah, we're about to head off the rails.
Yeah, and my vehicle was a giant fire ant. It was a giant fire ant. I mean, I think too many people have been watching what's that movie? The Lost World? Or what's that with Matthew, what's that dude? Danger Will Robertson. Danger Will Robertson.
Oh yeah, Lost in Space, yeah.
Lost in Space. Yeah.
Lost in Space, yeah.
Oh man, you're dating yourself now.
Yeah, man. I don't know what to tell you, man. I just don't know anymore. But we got a lot of stuff we're going to be talking about. I want to end this right now because it's been going for a while, and I'm going to say this. Flat Earth Math, it's up to you to respond. You know how to contact John. You know how to contact me. You can put out your own video to respond to John. You don't have to come on anymore. But I will say this. Man, there's a lot of drama for your mama out there right now. And there's some people that's really mad at me, and they want to unsubscribe. Unsubscribe this guy. Unsub him. He's a bastard. He's a snitch. He's a rat. He's a son of a bitch. You can't trust this guy. He's going around killing people. He's an assassin. People telling me people say I should change my channel name to Flat Earth Assassins. Whatever, man. It's not what you know. It's what you can prove. You can't prove shit. All right? There are people I'm on this panel with. They know me. All right? You want to talk about me? You want to talk to me? You can do it. I ain't got no harm, no foul. I ain't got nothing against anybody. There are a lot of people that talk shit about that out there. They know who they are. But I don't do hit videos on people. And I don't respond to that kind of shit. I take ownership to what I say. All right? There are times where I fucked up and I said things that, just talking shit. But I mean what I say, and I say what I mean. If I say something that hits a nerve with you, then that shit applies to you. So fucking what? So what? You got people out there, they want to talk about the flat earth, they want to talk about this science, that science, put out their own videos, put out your own information, man. Talk about what it is you want to understand. But when you start putting my name into your videos and your hangouts, then there's only one purpose if you want to talk about me. You like the drama, you want to support the drama, you want to promote the drama, and mentioning my name puts asses in seats in front of their computers so that you can get these viewers and get these subscribers coming to your channel talking shit about Robert Bassano. You got people out there talking about me, don't even fucking know me. Don't even know me. They think they know me. They think they know about me. They think they know what type of person I am based on what I put out on a video. I am who I am. I'm going to always be who I am. You can say whatever it is you want to say. You can disagree with me. You can not agree. You can agree with me. You can tell me I lost my mind. Say anything you want to say. I ain't got no problem with that. I got no problem with it at all. If I said something, I take fucking ownership of it. Immediately. I own that shit. That's me. You don't like it? Fuck you. But if you're going to keep doing the videos, putting my name out there, floating all this shit around, go ahead, be my guest. You're doing it because you know the shit that I say and what I do puts asses in seats. You gets you viewers. I show up on you motherfuckers' channels, get you viewers. And present parties excluded, by the way. Present parties excluded. Those people who know who I'm talking about out there. There are those who are not going to give this shit attention. There are those who are just going to ignore it. Says, you know, I'm out here for the message, man. I don't give a shit what this guy said in a private conversation. That's between him and the person who recorded the shit. You're right. It is. It is. But I ain't giving that shit attention. It is what it is, man. You're going to let this shit hurt your feelings? Then, you know, whatever, man. Whatever. I ain't in this shit for popularity. Give a fuck how many people fucking watch this stuff, man. I gained 4 new friends. Real fucking friends. Not backstabbing, back-talking, backbiting, two-faced, hypocrite motherfuckers. Who tell you one fucking thing, yeah, I'm with you, bro, I'm with you, bro. And then the next minute, when they want some fucking attention, they want to make a little fucking pocket change and shit off this bullshit-ass YouTube stuff, they'll turn on you like a fucking rabid dog. And those people know who they are, too. I ain't never fucking turned on anybody. I ain't never talked shit about anybody. If I do talk shit about someone, I go straight to that fucking person and let them know. We have a private fucking conversation. We change private emails. And then when motherfuckers sharing emails, they're supposed to be private between me and one other person, and sharing it with the whole fucking community, that's some childish ass fucking bullshit. If I send you a private email expressing, you know, some of the frustration that maybe you're going through, and you're going to share it with everybody else, that says a lot about your fucking integrity. Instead of talking to me straight about it, you're going to share it with you and your mama and your brother and your uncles and aunts, your boyfriends, your butt friends. Come on, people. I don't care who says what they say, how they say it. It's an open source community. Period. I can say whatever I want to say on anybody's channel, okay? And stay on fucking topic with what they're discussing. Anything else that happens with that person, that shit is, I don't care about that. All I care about is the content of what they're putting out, what they're discussing. Does it make sense to me? Do I agree with it? Do I disagree? Do I have more questions? Yeah, absolutely I do. But anything else they do in their personal life, I don't play into that bullshit. What people do behind closed doors, that's their business. But I don't fucking record people's phone calls. Except for NASA. Period. Friends don't do that shit to each other. And if you guys want to go with that and run with it and give that individual the attention that they've been literally begging for on their hands and knees, go for it. Go to that motherfucker's website. Listen to his shit. But I'm not going to do what you guys think I'm going to do. I'm not going to do what you think I have done. I'm not going to even think about engaging in any type of smear campaign, libel, or defamation of any one individual or group of people just because it's something you all want to hear. It's something what you enjoy to hear. You get off on that shit every fucking day on YouTube. I wake up just for entertainment purposes. I don't even watch the news anymore. When I'm bored, I turn on YouTube and listen to y'all bullshit ass drama. You'll get on topic and talk about something interesting, and then you'll just go off on a fucking tangent when you run out of shit to talk about. But then when some bullshit comes up, oh yeah, that's the hottest trending thing to talk about. Robert BASSANO. You start mentioning his name and shit, everybody comes out of the woodwork to listen to what it is you're saying, talking shit about the person. That's not what I'm about. I've never been about that shit. Ever. I never will be. I ain't got no problem with any of you out there. Any of you. What I have done is try to share a shitload of information that I have with all of you. And to date, there maybe been a handful of people to download maybe 25 documents. I ain't trying to set anybody up for anything. I ain't trying to make anybody look bad. I said what I said. If I call people out there ignorant asses, dumb asses, don't know what the fuck you talking about, if the shit hit a nerve, then it applies to you. Look in the mirror. I know who I am. I know what I'm doing. Period. Period. You can listen or don't listen. I don't care. I really don't care. Am I going to go away? Hell no. Because ain't nobody doing what I'm doing. I'm putting in real fucking work, people. Real fucking work. Real work. Trying to collaborate with all of you. Y'all gonna fucking run with some bullshit ass stuff you hear. And I do say bullshit. That was me talking, saying what I wanted to say, how I felt. You heard it. I own that shit. That's right, I said it. You can't get over it, then fuck you. Period. Other than that, my door remains open. I ain't going away. This shit ain't paying my bills. And I ain't doing it for shits and giggles, for laughs, for attention. I want you to see what it is I've seen. I want you to hear what it is I've heard. I want you to read what it is I'm reading. Because you may see something, hear something, know something that I don't know. Maybe I need to look at. But if you want to stick with the drama for your mama, you know where to go for that shit. Planete Veritas' YouTube channel ain't the place for that shit. Don't come to my channel. Period. Period. I said my piece. I stated my position, and that's where I stand with that shit. I don't believe the whole fucking earth is flat. Period. And I do mean the whole earth. That means the landmass, the waters, and the atmospheres of the whole earth system. The ground we walk on is relatively flat, undergoing flattening, and the water always finds a level surface. Like we're in some damn cereal bowl. But the atmospheres above us give us a view that's not consistent with 6.5+ billion people living on this earth. And because they look at something from a balloon or a rocket or from a plane, their idea has been convoluted. Period. Convoluted. So I said my piece. I'm out. I don't know when we're going to do another show. We might do one soon. I don't know. But in the meantime, I got papers to write. Got 2 weeks left on 2 courses that I'm finishing. And I got some more courses starting up. Oh, and just this announcement. Changed my major today from applied physics to computer science and machine learning. I learned something about physics that was put out in the Atlantic magazine online that completely discouraged me from wasting my time studying applied physics, because I'll never go into the quantum mechanical research realm, and the basic information about physics, finding other particles and, on smaller levels. Physicists have agreed worldwide they haven't found anything in the past 30, 40, 50 years. They haven't found anything new. And they can't. What they were expecting to see is not there. So I'd be wasting 2 years of my life studying something that basically when I'm done, people say, what did you learn? And I'd say, I just realized I wasted 2 years. I didn't learn shit. Because I'm learning it right here with you guys. I'm learning here with you guys. So I changed my graduate major to computer science and machine learning. I'm going to continue with the graduate certificate in AI at Stanford. And that'll be that. No more physics graduate degree for me. I read one article that changed my mind completely. And the stuff we've been doing with John has been interesting as well. And that opened my eyes completely. So thank you, John. Thank you, Marcus. Thank you, Robert Shortman. I look forward to many more conversations and, a continued journey towards finding the truth of everything that we've been told. is where we are, how we came about, what we're supposed to be doing. All right, guys. Thank you. Thank you all. Anything to say, Robert?
Yeah, thank you. Brilliant. Good
Marcus?
show.
Thank you.
Thank you, guys. Johnny?
I'm good.
All right, bro. I'll touch base with all you guys offline, and it's a wrap. It's not what you know, it's what you can prove. Take care, people.